In this video, we're going to explore finding probabilities and values in a normal distribution. First, whenever we talk about the normal and standard normal distributions, we're not changing the area or the area shaded. Those are actually going to be the same if I overlapped both the graphs. What's changing are the values. We're standardizing when we go to standard normal so that the mean is 0 and the standard deviation is 1. But how the graphs themselves look will be exactly the same. When we see those terms cumulative area and probability, we're talking about the same thing as well. And lastly, with Excel, we actually are making the process easier because we don't need to actually convert it into the standard normal. Excel's formulas will accept the given value we have, the given mean, and the given standard deviation. We can plug them directly in without doing any kind of conversions into the standard normal. And that can save us some time. So if we ever need to find a probability, we're first going to graph it on the normal curve, and then we're going to plug it into the correct formula. So say we're looking at IQ, where we've got a mean of 100 and a standard deviation of 15. We want to know what's the probability of IQ being less than 85. Now if I graphed both the normal and standard normal, I'd end up with the exact same graph. The difference being that on the normal, my values are 100 and then plus or minus 15 for each standard deviation. And on the standard normal, the mean is 0 plus or minus 1 for each standard deviation. So if I solve this problem with just the normal distribution, I'd be looking at probabilities x is less than 85, so I just use the typical norm dot distribution. Directly plug in 85, directly plug in 100, directly plug in 15. Put that in Excel, and I get just under 16%. So I'd say the probability of having an IQ less than 85 is just under 16%. Now if I standardized it using the standard normal, I'd get a z-score first, and that'd give me -1. So then I'd plug all my values into the same formula, the difference being that my given value is now -1, my mean is 0, my standard deviation is 1. However, when I solve it, I have the exact same probability. So it doesn't matter whether I use the normal or standard normal, my probabilities, my areas are always still going to be the same. Now sometimes you need to find the values when you're given a probability. And to do this, we have a new formula called the norm.inv, the inverse. What we do is we take our probability that we're given, we take our mean and our standard deviation, plug them in, and it'll give us the corresponding value. And if we're looking and recognize that that is looking to the left. So if we're looking at the probability to the right, we have to do inside here 1 minus that probability. Just remember, the complement. It's always the complement of the probability. So you got to look at where's the probability. In this case, it's inside. So our notation, you're going to see this a lot, is you have a capital P and then a sub-value, and that's recognizing a percentile rank. So in this case, say it's P sub 83, that's the 83rd percentile. So that's 83% and below. So that's like shading to the left of 0.83. So let's look at some examples. Say again we were back to IQ, and I want to look at the 16th percentile. So that's looking at 0.16 and below. So I can plug in those three parts into that norm.inv. So here's my percent, and I use the 0.16. Here's my mean, here's my standard deviation, and that tells me that the corresponding value would be 85.1. And you see I wrote it a little bit different here because what we say is the probability of x being less than 85.1 is about 16%. Which, if you think back to where we found probabilities, that's very close. Now say we want to look at what's the top 16%. So you got to think about this in this regard. The INV formula finds everything to the left. If we want to look to the right, we're looking at the complement of the percent. So wherever we talk about percent, we need to find its complement. So in this case, that's inside the formula. So here, instead of putting 0.16, we put its complement, which is 84 hundredths. and then we put the 115, and we get 114.9. So we'd say just or 84% probability being greater than 114.9 is about 84%.